if I knew this was going to be recorded, I probably would have put, dressed up a little bit and, something besides jeans, but oh well. As mentioned, my name is John Clingan. I work for Oracle. Prior to that, Sun. Was actually a Solaris specialist selling to big honking servers and Sun storage and all that stuff, and moved into product management. I was also a Java developer and sysadmin in previous lives. So, became product manager for GlassFish and Java EE. In case you don't know, GlassFish is a reference implementation for Java EE. It's also an open source project and a commercial product. So, out of curiosity, you see, one of the reasons I like to talk is you think you're going to learn something, and I get to learn something too. So, question: How many here are actually developing on a Java EE app server? Raise your hand. Well, okay, good question. Actually, an excellent question. Let's actually. So, how many Tomcat? Raise your hand. Okay. And how many are using more of like either the web profile or the full Java EE platform? Okay. Has anyone here actually done any WebSocket development? Raise your hand. Oh, good. So all look really smart. And no one can challenge me. No, just kidding. So I like to present in a very back and forth manner. So feel free to ask questions at any time. I like to keep things very informal. And I guess maybe I'll get started. And I apologize. You can ignore that. This isn't my slide deck. Java 1 is next week, so I'm like heads down and everything is Java 1. It's like, oh no, I got to do a presentation at the SDJUG. So for some reason I couldn't find the presentation, the exact deck that I used at the Orange County Java user group, which is kind of my home Java user group in Irvine. I'm actually out of Huntington Beach. And so I grabbed someone else's. So if you see me kind of looking funny in this slide and trying to figure it out, because I stole someone else's presentation in the meantime. But anyway, I'm going to do a little bit about Java EE7. How many here are familiar with Java EE7 features and technologies? Oh, okay, interesting. Okay, more questions. How many here are developing to Java EE6 APIs? Raise your hand. Okay, that's pretty good. Java EE5? Okay, so it seems like people have mostly, moved on to Java EE6. I'm going to give a primer on WebSockets and into some sense of deep dive, some slideware, some coding, and let's see, and talk about, in particular, the WebSocket API, which is a new API for Java EE 7. So this is basically the themes of Java EE7, right? So Java EE7 was launched in June 12th of this year, so it's actually quite new. And if you go to oracle.com/Java EE, there's kind of a landing page for where you can learn all about Java EE and Java EE7 in particular. There's a white paper there, and we also had this launch where you can go just listen to all the spec leads talk about the features that are in Java EE. Those are also on YouTube. The whole series is probably 15 to 20 20-minute videos by the spec leads, including Red Hat and IBM. So Red Hat is the spec lead for CDI. How many here use CDI? Context and dependency injection. Okay, interesting. I was hoping for more hands, right? Because that's actually a great API. CDI and Beam validation, and then IBM owned the batch API. And so you can learn about all the technology updates. This is kind of one slide that just covers the top 3 themes that we kind of align a lot of the EE7 features with. First and foremost is HTML5, where we've basically added supports for WebSockets, obviously this presentation, JSON, Servlet 3.1, actually JSON processing. It's kind of our approach to solving, binding JSON objects to Java objects. It's kind of a 2-step process, and I can talk to that a little bit. Servlet 3.1 NIO, non-blocking IO, falls under that. And then JAX-RS 2.0, which is a pretty major update to the JAX-RS API. So how many here actually have used JAX-RS as an API? Okay, excellent. Interesting. And so how many here actually do client-side browser development, or kind of responsible for building apps that actually communicate back to the server versus writing back-end apps? Do you guys actually write apps in the browser? What do you use for the user interface?
We got everything, JSP, JSF, they all have JavaScript components.
Okay, and all JavaScript, and so, okay, and the people that didn't raise their hands, how are you using JAX-RS out of curiosity? Just a couple, if I want to.
Services a lot.
So server-to-server kind of calls? Interesting, okay, good. A lot of focus has been put on developer productivity. So we really want to move the platform towards basically just developing toward annotated Java objects versus XML configuration. And that effort started with Java EE 5, and then Java EE 6 took it a step further, Java EE 7 took it another step further, and now we're kind of brainstorming and in requirements gathering mode for what should be in Java EE 8, right? But since we just launched Java EE 7 just a couple months ago, I won't focus on that too much. One of the interesting things is there's multiple bean models in Java EE 7, right? You've got JSF managed beans. You've got a managed bean spec that kind of is becoming the glue that kind of ties together the component model. You've got CDI beans, and you've got enterprise Java beans, right, in the platform. And so what EE 7 does is it begins to kind of bring all of those specifications together toward a single component model, okay? And anyone here using JSF, in JSF development? So interestingly enough, JSF managed beans are heading toward deprecation in favor of CDI managed beans. Again, CDI is kind of becoming that glue that ties a lot of the pieces, or a lot of the parts of the platform together. But don't freak out or anything. It'll be around for a long time, but we're trying to get people to move towards CDI. And then on the server side, batch. There's a new batch API for basically running batch jobs. The concurrency utilities for Java EE platform. Java EE doesn't like it when developers spawn threads on their own because it's unmanaged. The server doesn't know what you're doing. You can't use a lot of the EE features like dependency injection and so on. And concurrency utilities basically let you, like a lot like the Java SE concurrency utilities, it's concurrency utilities for the EE platform. So you can actually submit jobs to a thread pool and they'll run concurrently with other jobs. And so you can kind of delegate work off to other threads during a request. And then we've greatly simplified the JMS API. Sending a message, I think, was like 18 to 30 lines of code somewhere in there, depending on how you angle bracket and stuff, I think. And now you can just do it in a couple lines of code. You can actually submit a message to a queue. So we did a lot of work there. And there's a lot more to Java EE 7. Okay. So, WebSockets. So developers, folks like you have been trying to develop highly dynamic applications that are competitive in the marketplace. And basically that requires you to find out, or find a way to get data from your server, or from your client to your server and the server to the client. Historically, it was just HTTP, right? Request, response, request, response. And then other approaches kind of came along that basically allowed the server to more proactively provide data to the client, right? And some of these approaches, like polling, long polling, using Comet and Ajax, can be somewhat complex because at the end of the day, underneath it all is HTTP, right? Which is request response. And so anything that layers on top of that heck is too strong a word, right? But you're trying to solve a problem in a way that HTTP wasn't designed to solve, right? So That's where WebSockets come in. So WebSockets, well, has anyone here actually done socket-based programming using like, you know, socket, the socket API? Oh, actually, good chunk. So this will actually be very, very intuitive in a lot of ways. So what's interesting is, if you take a look at developing sockets, you know, a client makes a request to the server, and you've got this very low-level connection, and of course HTTP layers on top of that, right? But this connection is basically a long-lasting connection. Either the client or the server can terminate it, and either end can send data back and forth whenever they want and simultaneously, right? Unlike HTTP, which is I make a request from the client and I get a response from the server, right? So it's bidirectional in full duplex, okay? This is actually a standard defined by the IETF. So basically the industry is adopting it. Java's adopted it with the WebSockets JSR. I think it's, oh, here it is right here. The W3C is defined a JavaScript API for WebSockets. Does anyone here actually use that? Okay, I think I already asked if anyone's done WebSockets things. No. So basically there's an API now, a standard API that you can write to use WebSockets, okay? And I think it's still in a candidate recommendation. I don't think it's final yet, but most of the browsers support it, okay? And I'll have a slide that'll kind of help you navigate that a little bit. So the approach that WebSockets basically takes with Java is, actually in general I should say, is all communication starts out as an HTTP request. One of the nice things about HTTP is that, you can come in by the way. Mm-hmm. Oh, anyone that comes in late has to present a slide.
It's like this one right here.
Okay.
You work there.
Okay. So, one of the nice things about HTTP is basically everything on the internet supports it, right? So, to establish this bidirectional pipe between a client and a server, the communication actually begins as an HTTP connection. So the client makes a request to the server, and then it basically, as part of the HTTP request header, it requests an upgrade. So HTTP 1.1 actually specifies how to upgrade a connection from HTTP to another protocol, a higher level protocol. And that's actually what WebSockets uses. And what's nice is because, again, it's HTTP, it goes through proxies, it goes through firewalls, and routers, and anyone here in the security department? So you're probably kind of wondering, oh, yeah, so now someone could probably write Telnet, right? That goes through firewalls, and, theoretically speaking. And after you make this connection, you actually have basically this pipe that you just send bytes or text back and forth on. Once you do the upgrade, the HTTP protocol is gone, it's done, right? And that actually makes processing extremely efficient. And the latency for making requests between the browser and the server is actually very low because, again, there's no processing of HTTP headers. And once you make that connection, it's, like I said, it's just basically you're sending bytes back and forth. And with WebSockets, you as the developer, you own that higher level protocol for how your client talks to the server, right? So you'll kind of have to work on creating some standard communication mechanism, some messaging format that's proper for your application, right? And what's interesting is if you think about TCP/IP, or sockets in general began, as a very low level API, and then all these higher level our internet RFCs came along and layered on top of it, like Telnet, SSH, FTP, HTTP. And what's interesting is now with WebSockets, it has the opportunity to do it all over again, but at a different level of abstraction, right? It'd be interesting to see how perhaps some other standards might layer, or communication protocols might layer on top of WebSockets. But for now, we as developers, we own every aspect of that communication once we establish the connection. Okay. No headers, no security overhead. Okay, so for the security guy. To clarify that, with the WebSocket standards itself, the security basically is enforced as a part of the HTTP handshake, right? So that means if you want an encrypted communication line, then you're going to connect it with HTTPS, right? And actually, the WebSocket protocol uses WSS, right? Instead of HTTP, it's WS for WebSocket and WSS for a secure socket, right? But really, that first connection with the handshake is going to be, SSL. If you want to do some kind of authentication, then you're going to probably have to do that through the HTTP-based connection, whether it's certificates, certificate-based authentication, form-based, or whatever, right? It has to happen really at the HTTP connection aspect. But once that's done and the connection is upgraded, then if you want to do any security above and beyond that, like for example, encrypt, if you want to do an extra level of encryption for encrypting, credit card numbers and stuff, if you're sending them back and forth, it's up to you to do that yourself as a developer, if you want to take it to the next level. There's also ping and pong frames. So when I mentioned that you own, as the developer, all of the the communication protocol between the client and the server, there is a little bit of standardization in terms of the communication in that there's ping and pong frames, right? Where if you want to know if the connection is still alive, for example, if it's a WebSocket connection, then you can send a ping. And then the server can send back a pong, and there's a formal definition for how that is actually defined at the WebSocket layer. And then I believe there's also frames for like a control frame that says this is a text message, this is a binary message. And as far as I know, that's really about it. Okay. And once you connect, you send the messages. Again, it's full duplex. Clients and server can send data back and forth simultaneously. And when you're done, you end the connection, right? So it's basically a close. And when you do a close, the other end will get a close message, and you'll see that here with some code, I think. So first, there's the handshake request. Oh, sorry, this is an animation slide. Remember, I borrowed this slide. I'm gonna try and keep up, I guess. There's a request. There's a handshake response saying yes, I'll upgrade the connection to WebSocket. This is what that request basically looks like. So in this case, we're getting we're going to a chat application, and the host name is server.example.com, and this is what I was talking about earlier. This is that upgrade HTTP header, right? And it's going to upgrade the connection to WebSocket, and that's pretty self-explanatory here. Then there's a security key, basically that ties the connection between the client and the server. The origin is where the request is coming from, and then there's also the ability to define, kind of like HTTP, when you make a request. You can specify, like with JAX-RS, I understand XML and JSON formats, and then part of the negotiation is which one to use, right? The server can say, well, I want to use, first the client can specify, I prefer XML over JSON, and then the server can say, well, I don't support it, so here's JSON, right? JAX-RS can do that. And if I'm speaking too fast, it's because I had a lot of caffeine, I apologize. So same thing with WebSockets. You may have multiple protocol types. Let's say you're developing an application, and maybe it'll be more feature-rich if you're running from a browser on a desktop versus a browser on a phone. And so the application might support multiple types of multiple levels of a protocol that you define, right? This is your own protocols. You might define a chat protocol, and then if it's a really feature-rich browser, maybe you define a super chat protocol, right, that's more feature rich. And then the client and the server negotiate and decide which, or the server can respond with what it's going to support. And I believe that the order is the priority, the preferred priority. And then the response, basically, from the server says, okay, this is upgraded to a WebSocket, and we're going to use the chat protocol. And at that point, you've got a connection that you can just start writing bytes or text on, like binary or ASCII, basically. And at that point, you're connected. And once you're connected, there's both in the JavaScript API and the Java API, basically it's like a callback mechanism where once a connection is open, a callback method is called, if you define an open method via an annotation, and you'll see this, it'll invoke that method. So maybe in your code you'll say, well, if a connection is open, then I want to do some initialization, right? And you have an opportunity to do that. There's a hook when the connection is open that you can tie into. Then you can just start sending a message. The client sends multiple messages to the server perhaps, and then the server responds. There's also, so every time you get a message with both the JavaScript and the Java APIs, there's basically, again, just like the open event, there's also an on-message event. So whenever an event happens, it'll either call out to a JavaScript function, or in the Java API, it'll call out to a Java method. Okay? And there's also use cases or situations where you're going to run into a communication error. Maybe it's a badly formatted message that the server doesn't know how to parse, right? Or it could be something underlying in the actual stack. Some sort of exception is thrown for whatever reason that's going to generate an error message, and it'll call either in JavaScript on error function, or in Java an on error method. And then it'll continue processing messages. Just because you get an error doesn't mean it's going to close the socket. It just means it can't parse the message, depending on the nature of the error. And then there's a formal close where either side can close the connection. Ooh, isn't that pretty? Okay, this is, I apologize, and I don't expect everyone to be able to read this, but basically there's the JavaScript WebSocket API, and I can show you some examples of it here in the IDE when I pull it up. Now, this gets back to the fact that this is kind of support for WebSockets has been evolving in the overall internet infrastructure. So what basically this is, if you go to caniuse.com/WebSockets, and basically what you see here is the versions or which versions support WebSockets, which versions of which browsers actually support WebSockets, right? So at this point, if you want to look at the current version, let's see, yellow means, where's the legend, I forgot. Top right. Yeah, partial, sorry, the green and yellow don't really come across very well, but basically IE10 fully supports WebSockets, but anything before that doesn't. How many of your users use IE9? Probably a lot, right? So that's where what's interesting is you may want to look at frameworks out there, or perhaps yourself handle use cases where you're, well, if I can't use WebSockets, I'll fall back to REST calls, right? Or some other way of handling your dynamic application. But just keep in mind that everyone's, the vendors are just, or have been adding support. Not everyone is fully there in some cases. Like, I'm not sure what the date for this one is because it changes quite a bit. But the mobile browsers, like the stock Android browser doesn't support WebSockets yet. But the embedded Chrome browser does, right? So if you download Chrome on your phone, how many of your users actually do that? Probably very few. So just keep in mind that not all the browsers, your target audience, may support WebSockets. Also keep in mind that proxies have to deal with long-lived connections where historically they might not have had to. So some proxy servers may basically after a certain period of time just force a timeout and force the client to reconnect, right? And so what you're starting to see is more proxies, like the Oracle Traffic Director, are natively starting to support WebSockets. So if they see a WebSocket connection coming through, then they'll actually hold that connection open and not try and close it. So from a Java perspective, JSR 356 is the Java API, I think it's the Java API for WebSocket. I always think it's WebSockets plural, but it's singular. As with all Java EE JSRs, the beginning with a certain version of the Java community process, all new JSRs have to be basically publicly available in terms of the mailing lists for the expert group members is all public. You can watch them talk about these JSRs and the features that are going to go into the platform. You see the conversations they have. You can join in as developers if you're interested in a particular JSR. You can go take a look at the implementation. Basically, they have to be publicly available, and the implementations have to be in an open source license. And in the case of WebSockets, you can go to java.net/project/WebSocket-spec, and you can go back and look at all the messages that were, the conversations people were having in the definition of the spec. And now they're already starting to think about what do we do in, the next version of WebSockets since 1.0 is done. And again, this ships with Java EE 7. And Java EE has basically two profiles. There's the web profile, and this concept of profiles was introduced in Java EE 6. And the idea is, there's a lot of vendors out there, like Calcio, for example, that simply weren't interested in doing a full Java EE platform because their target customer base was, mainly developing a certain type of application that was more web-centric, right, versus using JCA and JMS and stuff like that, and building out a full platform. And I don't mean to put words in Calcio's mouth or anything, I'm just giving an example. And so the web profile is really targeted at developers who are developing web applications. And that means I got a browser talking to a server, I run some business logic, and I talk to a database, right? Generally speaking. Of course you have JAX-RS to go off and talk to backend services like Twitter perhaps. The WebSocket API is actually included in the web profile, okay? Just to let you know. And then you have the full-blown Java EE app servers like WebSphere, WebLogic, and GlassFish. And obviously, WebSockets is also required as part of the full platform. Okay.
What is the number of actual clients can connect to the server via WebSockets?
How many clients can connect to a server via WebSockets? There is no defined limitation. There's practical limitations based on resources. So I think with GlassFish we tested 60,000 concurrent connections. And we were passing data back and forth at various sizes, right? Small messages and large messages. And we were kind of doing some performance testing just to test out the reference implementation. So it can scale, quite high, but just keep in mind that when you have WebSocket connections, you're also going to have sockets open on the server, right? And then you have, an application behind that has to, that may want to manage those connections. If you think of a chat application, it's going to have to keep a reference to everyone in that chat, right? Across all the chats in this chat server, and that's going to take resources. So it's really limited by the underlying hardware, as far as I can tell, and how good a developer you are.
For the Node.js, I've done some Node.js work, and some of also .NET developers usually similar. The overhead is very minimal in those aspects between Node.js. Can you compare those things with the Java implementation?
Well, Node.js is not multi-threaded, right?
Yeah.
So they're going to be constrained by how many requests can be handled and managed from a single core. And then you'll spawn as many Node.js runtimes as you have cores, basically. So with the JVM, because it's multi-threaded, you'll be able to handle many more per server, is my guess. And on that topic, you might want to listen into the Java 1 technical keynote. I think it's Monday next week. So, and you'll see some specific points around this topic.
Clarification.
Yes.
So, if I understand you right, we don't handle the threading behind the scenes. There is part of the specification, there's an engine that manages its own pool of threads. We simply subscribe to it, the web page negotiates the connection, we somehow, when we connect to it or we issue the page, we've got to handle, and we receive events, but we don't actually have a open socket. There's a service somewhere, and it just sends us events when we get them.
Correct. In that way, it's a lot like servlets.
Okay.
Right? It's very similar to servlets in that way, where you just get a request, and you manage that request, right? So basically, maybe when I code, I can talk a little bit, and if it doesn't answer your question, then just feel free to ask it again. Yeah. Question.
Yeah, let's say you have one browser that's have a WebSocket connection to the server, and you have additional area in your browser that you want to update it on real time. Can you have multiple WebSocket connections on one particular browser?
Can you have multiple WebSocket connections within a browser? As far as I know, you can, because you may want to have multiple connections to different services, right? So what you'll do is you'll basically just spawn a WebSocket connection and just store the reference in a different variable name, right? So WebSocket 1 goes off to server 1, WebSocket 2 goes off to server 2, you might store them in variable WS1 and WS2.
And that's going in the same pipe, or?
That'll be different pipes. And you could probably make multiple connections to the same physical server too. I actually haven't tried that, but you probably can, and I don't know of any constraint to that at all. And if that were, the place I would go to find out would probably actually be JavaScript, spec, and see if there's any kind of limitation. That's not really a Java side limitation. From the Java API, there's a concept of server endpoints and client endpoints, right? Once you, basically, the difference is, who initiates the conversation. That's the client. But the API is very similar. When a connection is established, onOpen is called. When you get a message, onMessage is called, right? So the API is similar. And you can have as many of those as you want from the Java client perspective. I don't know if there's any browser limitations. And who knows, maybe there's one browser does it and the other one doesn't, right? But I don't know the answer, but it's something just to research.
Okay.
Yes?
So do we have the concept of connection pooling in this space, or it has to be like a connection for every single?
Is there the concept of connection pooling? That's not defined in the actual Java spec. So that would be up to the implementation to figure out those details. So I can't think of, now let me think. I suspect what's going on from the Tyrus implementation. So Tyrus is the reference implementation that Oracle wrote, because they were the spec leads, so they were responsible for the reference implementation. I suspect they're using non-blocking I/O calls, right? So they aren't going to necessarily, they don't have a thread per connection model, right? And I don't know the details of how they actually implemented it, but that sounds to me like it's an implementation detail.
So one other question is, how do you compare this to REST? So behind the scenes, can we, for performance reasons, can a REST call be really a WebSocket call so that you gain performance?
Interesting. can REST layer on top of WebSockets for increased performance? Is basically, I'll rephrase the question that way. And I would say it'd probably be slow. And the reason I say that is because what you would do is you have WebSockets, and REST is HTTP centric, so you're gonna have to layer HTTP on top of that anyway, right? It's pragmatically speaking. And you're just adding a layer that doesn't need to be there. I mean, REST is really HTTP over TCP/IP sockets, and there's no reason to add WebSockets to that mix. I can't think off the top of my head a value proposition for that. It won't make it go faster than a native TCP/IP socket because the REST stack still parses HTTP headers as part of the API, right? It's HTTP centric. So, and WebSockets is HTTP centric only until the connection is made, and then it's up to you, the developer, to define the verbs that go back and forth. Now you can do more than get, put, and delete, and right now you can do anything you want. Okay. How are we doing on time? This is like this is kind of like going to Vegas. Right? There's no clocks on the wall. Just keep going.
Free drinks.
Yeah, free drinks. Yeah.
Next time.
Next time, yeah. So I mentioned Tyrus is the reference implementation, so you can go and take a look at it. Now, the WebSockets API doesn't have to run on top of a Java EE servlet container, which is if it's running in an app server, it's generally layered on top of the servlet container, but it doesn't have to be. You could, as long as you have something underneath that manages the HTTP upgrade aspect and complies with the API, then you can do WebSockets. So, for instance, you can do WebSockets over the Grizzly connector. So Grizzly is a project also on Java.net that basically is an NIO connection management framework, right? And it supports HTTP as well. So, but it's not a servlet container. So the WebSocket API can layer on top of, not on top of app servers and other things. But if it layers on top of an app server, then you have to use servlets, and I think there's some implementation requirements if it's running in an EE environment. And it's of course integrated in the GlassFish 4, which is the Java EE 7 reference implementation. Out of curiosity, does Calcio have WebSocket support in their early builds or anything?
Yeah, we've got that support in an early build of our new technology. Yeah.
Okay. So can developers get access to it right now, and do you know?
That would be a good question. In the open source, anything.
Sure.
I'd have to check on that.
Okay.
That we're working on.
Well, the reason I say it is because, out of respect for the host, I don't want to say, go try GlassFish and use WebSockets, right? So I just want to make sure that, there are other implementations that will be out there, but because
Yes.
GlassFish is the RI, it's out there by default, by definition. But other vendors like JBoss and even Tomcat is working on it, Calcio and so on.
Right, certainly at the top of our list.
Yeah, and Jetty as well is working on WebSockets. I'm just not sure what stage of their implementation they're actually at. Now you want to take an early break. This might, before we actually get into the API, maybe it's kind of a good breaking point.
That's fine.
Okay.
Considering a lot of people don't want it.
Yeah, I was gonna say, that's okay. It's an interactive session, go ahead and take 10, we'll take 7, we'll start back up around 8 o'clock.